Okay. Right, put the iPads away. Locus. This is something that you might see on an ACT test about the word locus. It's not locust. You guys know what locust it means? A grasshopper. Okay. Locus. Locus is a set of points that describe a situation. The most common thing for these, it's easier to draw pictures to explain. And one of them we've done quite often. Tanya, get up. The most common one, going back to 7th grade, whenever, the definition of a circle is all the points equidistant from one single point. So like if they gave you a direction to draw all the points that are 2 inches from a given point, you would draw a point, and then you'd go out 2 inches, up 2, out. These we're just going to sketch. So you keep going out 2 until it forms a circle. And then you got to label what it tells you. Since it was all the points 2 inches, you'd have to label that 2 inches. So that's just the definition. That's what a locus is. Okay? Some other common ones is a set of points, we'll just say 5 inches from a line. Okay? So you always got to start off with the given. You got to draw a line. And then we got to put all the points that are 5 inches from that line. So what would you do? Huh?
We would just draw a line.
It'd be a line up here that's 5 inches away, right?
Yeah.
What else would it be? Because every point on this line is 5 inches from that line. There's more.
5 inches below it?
5 inches below the line. So then you just have to label it like that. Okay, another popular one or common one is, we'll just keep 5 inches from a line segment. So now you've just got a line segment. So you'd have to go up 5 inches, right? Down 5 inches. But then what do you do?
To
Go to the sides too.
What's it going to look like on the sides?
That'll be a vertical. I don't know.
Remember, you got to stay 5 inches away from the line segment. Right, it would be a half a circle because when you get to the end of the line, it's going to start going like this, right?
Oh.
Because it's got to stay 5 inches away from it. So what's that actually formed? An oval. Those are the most common ones. Here they got an example. Draw a line M. Oh, we just did that one. And then draw and describe the locus of all points that are 1 centimeter from the line. So you'd have to label an M. And then you'd have to go up 1 centimeter and down 1 centimeter. And then you got to label that it's 1 centimeter. So you got to put that it's 90 degrees to show that it's a distance. That's what that's supposed to be. So that would be the locus of that problem. Okay, this one. Describe the locus of points equidistant from the vertices of an equilateral, equiangular triangle.
Oh, nice.
So when it says describe, the easiest thing to do is to draw a picture. So here we've got an equilateral, equiangular triangle. We want the points that's equidistant from the vertices. Now this is a construction that we did way back. Remember how you find the point? What we did here is we found a point in the center so we could circumscribe a circle around it. So how did we find that point? What do you got to construct to find that point?
Circle. No, yeah, it's just a bunch of gibberish.
An angle bisector.
It's either angle bisector or perpendicular bisectors.
No.
Okay? If you drew in the perpendicular bisector, every point on this line is equidistant from these two. Okay? The angle bisector is every point on that is equidistant from, oops, I drew that wrong. Equidistant from each side. Okay? So that and that would be the same distance. So, the angle bisector is equidistant from two sides, the perpendicular is equidistant from 2 points. So you would have to draw in 2 perpendicular bisectors to find that point right there. You don't have to draw the third because they all intersect in the same spot. Okay, here they went through it. This is a more complicated one. Lines C and D are in a plane, and they drew them. There's an XY coordinate. They drew them at a 45-degree angle. What is the locus of points that are equidistant from C and D within X units? So, what they did is they drew a circle, and from here to here is, they don't know what, so they just called that X. And this is also X, and that's also X, and that's X, right? So, every point on this circle right here would be equidistant from the center, right, from the origin. But they just want the points that are on the line. So it'd be this point, this point, this point, and that point. On line D and on line C, those are the 4 points that are all the same distance from the center. Okay, let me think of if there's any others that are pretty common. Okay, there's really only one other. I just mentioned it. I didn't say it. And that's the angle bisector ones. To find a point that's equidistant from each side of an angle, you would have to construct the angle bisector. So every point on this line is equidistant. It's not a very accurate drawing, but from each sided angle. Okay?
But that was from the last chapter, right? So we're just going over it.
No,